Greetings, Saintsmen. We're on lesson 11.7, which is the surface area and volumes of cones and pyramids. So here is our governing formula for this. The surface area for a cone or a pyramid, which is effectively going to be the same thing, right? We have talked about prisms and cylinders, which are effectively the same type of structure. They're categorized the same with regard to, we have these two bases, right? And then that they're connected by this lateral portion. Similar sort of thing with cones and pyramids, right? So we're going to have just a singular base, which we're going to find that area in the surface area. And then what we're going to add is 1/2 of, yikes, I can show you guys effectively like a shorthand proof for the formula in person of the perimeter times L. So this is how this is reconciled here. This is for effectively for a pyramid. B is referring to the base area. So it just depends on what our base is. What is the polygon base? And we can find the area of any polygon at this point, right? Regular, we have as long as we have a certain set of dimensions. For a regular polygon, it's actually pretty straightforward for us. We have a singular formula, right? 1/2 of perimeter times the apothem. And then there's also all those other sub-formulas within, like if we have a quadrilateral or triangle, or actually what maybe be even quote-unquote easier is if you have, let's say, like a pentagon that's not regular, is you could subdivide that figure into triangles and quadrilaterals, and you could take an area from there. This next portion is what's referred to, and I'll give you like what these lateral portions are, and this is what's called the lateral area, or what you're calculating here. So this is that base that's going to be around it. Now L stands for the slant height, and I'll show you what that is and why this all works this way. Okay. Real quick before I move on, this is going to be again for a pyramid. For a cone, it's the following. It's effectively the same, but we don't call the length around the figure a perimeter for a circle base. The length around a circle, of course, is the circumference. So it's just the circumference times the slant height. So it's effectively the same exact thing in terms of learning these formulas. So it's kind of an either-or situation. Give you guys an example of what that slant height is. So I'll show you guys how to draw here. I know me, the art teacher. Oh, goodness. My pen's really, my stylus is still really struggling here, guys. See, it won't even connect the bottom for me at this point. Here we go, come on. There we go. Okay, so I've created a rhombus here, but this is, by perspective, it's actually gonna be a square. So I'm gonna give it a right angle up there, right? If I have 1, I have 4. And I'm just going to take a single point above that rhombus. And then what we do is we're going to converge and take every vertex and connect it to that single point that's above, even if we cross over and overlap other stuff. Now, what they'll typically do to show that there's an x-ray is they'll go like a dash line on this upper half, right? And what our slant height is on one of these lateral faces, which is a triangle, right? We have 4 triangles in this pyramid. This right angle, or this altitude, which is the height of the triangle, is going to be the slant height. So it's not, this is where people get confused. It's not this lateral edge right here. No, that's not it, right? It's actually that perpendicular height, which happens in the middle, quote unquote, of that triangular face. So this is the way this formula works this way. It's actually pretty straightforward. It's 1/2 of base times height for this triangular face, right? Well, I'm going to take a sum of those, right? Because I have 4 of them, and that's going to give me 4 times those bases, right? This length down here. And that's going to be your perimeter, right? So that winds up getting multiplied up anyway. So it's one of those things where 1/2 of PL should make a lot of sense, because if I have triangular faces, that's 1/2 of lowercase b times lowercase h, right? The base length and then that altitude height. So let's actually employ our formula here. We're going to find the surface area. So here we go. So here is my cone. I made an ellipse, as you guys can see, that went where these kind of the foci, right, kind of wind up happening on that. They're widened horizontally. But I make an ellipse. I'm going to put a center in it, and then I just put a point above it and connect the outer left and right edges. And then what you usually do for a cone is you give a dashed line in the back to kind of give some perspective, like you have X-ray vision there. Here are our dimensions. So right here, so this height right here is going to be 12 inches. And this radius is going to be 5 inches. Now think about what formula we're going to employ here. This is the base, right? And then now we have to, that's the base area, and we have to add the lateral area, which is like that cone. They have to think like ice cream cone without the, without ice cream in it. That's just going to be lateral area. So it's going to be 1/2 circumference times slant height. So area of my base is going to be, it's a circle, right? Pi times the radius, which is 5 squared, plus 1/2. And how do we find circumference? Well, it's 2 times, or I'm sorry, it's pi times your diameter, and your diameter is going to be 2 times 5, which is going to be 10, right? And then we have to get my slant height, which we don't have. It's not given to us. The slant height is this edge right here. This is L. But look what we have. We have a right triangle, so we can just employ the Pythagorean theorem. So 12 squared plus L squared. I'm sorry, guys, not 12 squared. Yeah, it's 12 squared. 12 squared plus 5 squared is equal to my hypotenuse, which is L squared. 12 squared is 144. 5 squared is 25. And 144 plus 125 is 169, is L squared. I'm going to take a square root of both sides, right? Square root of 169 is 13, so that is your L. So we're going to take this value and plug it in back here. So this is where we have 13. So then I have 5 squared, which is 25 pi. Okay. Again, this is my base area, just for reference. Plus 1/2 of 10 pi times 13 is going to be 65 pi, right? 1/2 of 10 pi is 5 pi. 5 times 13 is 65, and that is my, again, my lateral area. And these are both in terms of pi, so we can combine. 25 plus 65 is 90 pi inches squared. Awesome. So now let's find the volume of a cone. All right, let's see if we can find the volume of the, let's see if it's a similar, no, it should be a different cone. Now, the volume, we did surface area, volume is going to be done a little bit differently. But remember, our volume formula was pretty straightforward for prisms. It was capital B times H. Here, it's just going to be 1/3 of that, and that's it. All right. Let me give you a new cone, and this is actually fairly straightforward to employ, as you guys can see, because there's only 2 variables, and this one is going to be the most complicated part. We do that if it's a cone or even if it's a pyramid. All right. Come on, there we go. So draw another cone. My ellipse, my point above it, connect my other 2 parts, and then I'm going to draw this height. Okay, right angle. This is 10 meters. And then this height here is 8.4 meters. I don't care about slant height here. I don't need to, right? It's going to be straightforward. It's going to be equal to 1/3 of the area of the base, which is pi times the radius squared, or pi times 10 squared, times my height, my altitude height, which is 8.4. So gentlemen, we just keep on moving here, right? We're going to have 1/3 times 100 pi times 8.4, which is effectively going to be 1/3 of 840 pi. right? I can actually do that in my head, right? Move that decimal 2 times. You guys remember that old trick? So it's going to be 1/3 of 840, which is actually divisible by 3, right? 8 plus 4 is 12 plus 0. So then punch that into our calculator, and we're going to get 280 pi. And then in this case, our volume is going to be in units cubed. So this is in meters cubed. Okay. Next, last part of this is we're going to discuss the surface area of a prism or cylinder. All right, so here's going to be a fun one. The surface area of a prism / cylinder, and we're going to do this in class a bit because this will be included in your next test, is capital 2B plus PH or capital 2B plus CH. P and C effectively the same thing, right? Again, we can separate the area calculation into 2 parts. The B is the base area, and we have 2 of them, right? It's the same on the top and bottom, quote unquote top and bottom. And then we're going to have the circumference times the height, or the perimeter times height, which is the lateral area. And here's the big thing. If you were to create what's called mathematically a net, right? You would unfold all those lateral areas and flatten them out, and effectively is going to make a rectangle, which is length times width. Well, there's your width right here, right? Or your length, which is that height, and then your width is going to be how many times around that circle. So it's going to be all those base edges and then times the number of sides that you have, right? So let me draw you a picture here. Let's draw this bad boy up. Let's see here. I'm going to draw a regular hexagon, and then I'm going to squish it a little bit for perspective, okay? And then I'm going to have 2 of them, and then I'm going to start connecting vertices left to left, top left to top left, top right to top right, right to right, bottom right to bottom right, bottom left to bottom left, okay? And this is regular. Which is good news for us, right? Because think about what we're going to do. If I'm given that this edge here is 4 feet, and that this right here is 5 feet. Okay, so let's do it. Let's figure out the area of the base. You guys ready? Well, remember what we have here. We have a regular pentagon, or regular hexagon, right? So the B is equal to 1/2 of your perimeter times your apothem. We got to figure out perimeter right here, right? Well, perimeter is going to be 5 times the number of sides, which is going to be 6 or 30, right? So I'm going to do that one here, and we now need to find our apothem, which is this right here, our A. So I'm going to just pull this guy out a little bit and blow this up. We've talked about this, the idea of kind of expanding and blowing it up so we actually see what we're doing. So we need to have X, and we need to find apothem here, right? And this is over here, the radius, quote unquote. But when we do this, remember, we're going to go 60 is 360 divided by 6, which is going to be 60, and then we're going to bisect it here to get that this is a 30. And some of you guys might have just memorized this by now, that in a hexagon, when we get to this instance, it winds up being a 30, 60, 90 triangle. That X, since this entire side is 5, is going to be half of that, right? Because it gets bisected by the apothem. And then the apothem in a 30, 60, 90, where you go short leg to long leg, we're going to go 5 rad 3 over 2, right? Because it's going to be just times rad 3. Okay? So then I'm going to have this as my apothem. So let's start to simplify. 1/2 of 5 times 6 is going to be 15, right? 5 times 6 is 30, 1/2 of that. And then times my apothem, which is 5 rad 3 over 2. Okay? And then I can continue to expand. 5 times 15 is 75 rad 3 over 2. This is the area of my base. Okay? So let's go work over here. I have 2 times my base, which is this. Gets plugged in right there. all right? Plus my perimeter, which we already calculated, right? That was this. That is just merely 5 times 6. So we're going to say pH, or 2. I'm going to put a over here, guys. There should be a 2 in the denominator. 2 times 75 rad 3 over 2, which you guys, I hope see an outcome that's going to be excellent for us. The perimeter being 30, and the height is just this number right here, 4. Okay, let's evaluate. Watch what happens. A lot of this is going to get simplified out. 2 and 2 factors out. I have 75 rad 3 plus 30 times 4, which is 120. And actually, we can leave it just like that. And this was all in feet. This will be feet squared. So there we go, guys. We can now find surface area and volume for three-dimensional solids between prisms and cylinders, and then cones and pyramids. So if you have any questions for me, I look forward to seeing you in class and also during my office hours.